Okay, today I'm going to talk about the 725 and its Browning defined mechanical triggers, which aren't totally mechanical. So I'm going to start off with some detail here, then I'll move the camera and we'll get more into a whole view of the action. But right now the gun has just been fired, the top barrel, which is the one closest to us. I'm holding the trigger back. The sear is still on the perch of that tree. If you don't know what the tree is, go look at my earlier video about the way a Satori recoil reset trigger works. It'll explain all the parts, the recoil block, the tree, the shelves, all that stuff. But for now, in the 725, the tree is essentially the same. It has a center shelf, it has the two side shelves. The center shelf is set forward again. The sear is held trapped on the top of that shelf right now with the trigger pressed all the way back by spring pressure on the shelf. When the gun fires, this piece is called the disconnector, and the disconnector is propelled upwards by the spring. So I'm going to just do that with a punch right now so you can see what happens. There's a sloped piece machined into the front of that recoil block, in the front of the tree. There's a pin across the front of the disconnector that rides up that slope and pushes it rearward as I push up on the disconnector. If I push up far enough, it actually pushes the recoil block far enough back that it disengages from the sear and resets the gun. This piece falls back down under spring pressure. Now if I release the trigger, you hear the click, it resets on the other sear. So dry firing a gun is exactly as I've described. This little bump in the spring propels that disconnector up. It pushes back on the slope of that tree. That disconnects the tree from the sear, and then when I release the trigger, that side shelf of the tree on the other side falls underneath the sear for the second shot. Okay, let's take a look at the entire action of the gun now. I've added a piece here that's actually just a little magnet stuck on the frame with a wire that acts as a pointer, and we'll use that in a minute. But the action of this gun is quite popular because the claim is that it's mechanical triggers and you can fire both barrels, dry firing. So it doesn't need inertia to reset the trigger. So let's go ahead and take a look at what happens when we do that. Now what I want you to notice is that the disconnector right here is propelled up in the air by this big coil on the spring contacting that protrusion on the bottom. Earlier guns didn't even have this. They just relied on the fact that the strut and spring come up in the air as this is propelled forwards, and it contacts the bottom of the disconnector and forces it up in the air. Now it forces it up in the air, and as it does so, the pin that we just looked at rides up that ramp and forces the recoil block and tree back far enough that they fall out from under this first sear. And in fact, you'll notice that the first sear ends up in its resting position after we fire the gun. So I'm going to go ahead and pull the trigger and hold the trigger back. And sure enough, you can see that that sear has dropped down and it's in its final resting position. Now as I let go of the trigger, you'll hear the click as the tree, the side shelf on the tree, falls underneath that second sear. So the gun can now be fired, the second barrel of the gun can now be fired just like that. Now you'll notice in this case, that sear does not reset. It's held on the top of that tree by spring pressure of the sear, just like occurs in a recoil reset gun when we don't have a shell in it and we fire the first barrel. In that case it's the center shelf, in this case it's the side shelf, but the principle is the same. So why doesn't this happen all the time when we fire the gun in a loaded condition? So let's talk about that. Let's go ahead and recock the gun here. And I'm going to use this Allen wrench to retard the motion of the hammer, make it come forward in slow motion. And I want you to watch the disconnector in this case. Right, so here's the thing coming forward. The disconnector is raised, but because it's slow, there's no momentum imparted to the disconnector. It doesn't go up any higher than its final resting position right there. Notice now that that sear has not been released from the tree. It is still trapped on top of the tree. If I pull the trigger again, it's just like we fired a recoil reset gun. It doesn't allow me to fire the second barrel. So how high does that disconnector actually go? Let's go ahead and push our little magnetic pointer down now. Put it right on top of there. So that's the final resting position of that disconnector. We'll recock the gun. Going to dry fire it again. And this time it will push that magnetic pointer up to its final or to the height that it actually travels. And you'll notice that's actually right at the bottom of the frame. So in fact, the disconnector is propelled upwards by that spring until it stopped by the frame. Now that's plenty of motion to reset the tree, pull it out from underneath that first sear. That ramp we looked at to begin with is, what that pin pushes on, the disconnector, and it pushes that tree back plenty far. But in the case of a loaded gun, it doesn't exactly work that way. So let me reset the sear here. And let's see what happens in the case of a loaded gun. Notice that, this coil doesn't actually impart motion to this until near the end of its travel. And in fact, right now, the shell has been ignited. Primer's gone off, powder is burning. That all happens very quickly. So this is being propelled upwards. It's moving up there. I'm contacting a ramp. And I can actually move up the ramp a little bit, starting to pull that shelf out from underneath that sear. But before that happens, the gun moves back enough that it imparts counterclockwise motion to this. And it forces that recoil block and tree back underneath the sear. They're heavy, and because the gun moves back, the acceleration causes force on that block to move it forward. Now, if it's a heavy enough load, the gun builds up enough velocity that it resets the sear just like a normal reset gun does. And that happens by that recoil block moving back. You can see it at the very back of the frame right there. So now, with a heavy load, I'm free to fire the second barrel just like I was on a recoil gun. The key is, with a light load, not enough velocity is built up in the gun. Now the recoil block in this gun is much smaller and lighter than the recoil block in a normal recoil reset gun. So it happens that with even 7/8 ounce light 12 gauge loads, some people have trouble firing these guns. There's a lot of variability, right? There's probably variability in the springs of the gun, but the most variability is in the person themselves. Do they hold a tight gun? Do they hold a loose gun? How much do they weigh? How fast does that gun come back before it stops? The amount of velocity and the speed of deceleration of the gun are key to whether that recoil block will reset the gun or not. So that could be fixable by installing a lighter spring in the trigger. I've read some people's claims that that is the case. I haven't tried it, don't know. But this is why these guns don't always work with light loads. If they were a true mechanical trigger, if there was enough mechanical motion, that is, we didn't depend on the inertia of this block going up, we had a bigger coil here maybe that came to rest in front of the bump, and it actually forced this up high enough that it would reset that sear, then we could call it real mechanical triggers. As it is, these aren't really 100% mechanical. They depend on inertia to reset, just like a recoil reset gun does.